students, welcome to all. In this session I am going to discuss you about the topic direction vectors, which is under the unit motion in a plane. So why I am teaching this direction vectors is so to represent any direction in physics. So physics is a consolidated study of vectors and scalars. All the physical quantities in physics, it may be either a vector or a scalar. So a vector means what? It has a magnitude and direction. A scalar has only magnitude. So while dealing with a vector, so we need to focus about the direction. So how to represent a direction? So a vector is a quantity with magnitude and its direction. So in what way the magnitude is set? So in what way, that is in what direction the magnitude is set is given by the direction vector. So a magnitude multiplied by a direction vector will give the total vector. So a vector is magnitude multiplied by direction vector. So what is a vector? A vector is magnitude of that vector and multiplied by the direction vector. So it may be of any physical quantity. It may be of any physical quantity. A force is a vector. A force has its own magnitude. For example, 5 Newton force. If you take a velocity 25 kilometers per hour, that is a magnitude, but you don't know the direction. If I take a force, okay, of 5 Newton, this 5 Newton represents the magnitude. I don't know the direction of that force. If it is towards positive x or towards negative x, if it is towards y, minus y, z and minus z. So we have 3 dimensions. Clear? So this direction should be multiplied by that. So this direction vector should be placed here. This force magnitude should be placed here. If I want to represent the force as a vector, if it is simply a scalar, there is no need of representing this direction vector. I may represent it as force equal to 5 Newton. If I want to represent the force as a vector, I have to place this 5 Newton with a direction vector. That direction vector only I am going to teach you now. So what are the dimensions that we have? So I have a 1 dimension and 2 dimension and 3 dimensions. The scaling of the dimensions is 1 dimension, 2 dimension and 3 dimension. First I will let you know what is 1 dimension, 2 dimension and 3 dimension. Then I will proceed each way. Students, kindly make a note of all these things individually and be careful in listening to this and writing to this. It will be very better for you if you write it as in this format. Clear? Okay. So first I will take 1 dimension. Now I am going to discuss you about the 1 dimension. What is 1 dimension? It has only 1 axis. The axis is only 1. So the study is along only 1 axis. Either I can move forward, I can move backward. The axis is 1. So for example, how to represent, the axis while you are dealing with the graph. Either you have x-axis or y-axis. Yeah. So you know what is an axis. The direction it is denoted by an axis. Then I will draw this line. I will draw a straight line. Let this be a point O. This is a starting point and an initial point. If I am moving an object from this point to this point, if I am moving an object from this point to this point, let this distance be 10 feet. let this distance be 10 feet. Clear? Let this distance be 10 feet. The 10 is the magnitude. The 10 represents the magnitude, the displacement of the object from this and this point P. The displacement is OP equal to 10. The displacement is OP equal to 10. So I don't know in what direction the 10 has occurred, either to the left or right or top or bottom. I cannot just see the number and tell the direction. So to know in what direction the displacement has occurred, I have to introduce a direction vector, since a displacement is a direction vector. Okay, so you know what is a vector? A vector is a quantity having both magnitude and direction. So if I have a magnitude, I have to have something along with the magnitude to know the direction in which the magnitude acts. Clear, students? So I want to have a parameter that should be in which the scalar to know where the scalar is acting along. Clear? So here the displacement is OP, that is 10. This 10 is along what? Where? So either it is in the right hand side or left hand side or top or bottom. So for this I am going to introduce a vector, the term unit vector. This unit vector describes the direction of the scalar or the magnitude. Okay, so this unit vector, for x-axis the direction vector is represented by I cap. For x-axis the direction vector is represented by I cap. It means, why I am calling it as a unit vector is, unit vector means the value is 1. Unit vector. Unit vector means value is 1. Okay, the value is 1. When I multiply this unit vector with the magnitude of any vector, the magnitude will not get affected. So only I am placing a unit vector. If the magnitude of the vector gets affected, then it is not a unit vector. So I should place a vector to represent a direction such that the magnitude of the vector should not get affected. So only I am placing a unit vector. So a 10 multiplied by a number should get only 10. The 10 multiplied by a number should give only 10. And also it should show the direction. So what number should I multiply? What is the number that will give the 10 when I multiply it by 10? Obviously it is 1. Okay. So when I multiply 10 with 1, I will get 10. So this 1 represents a unit vector. So I will not just mention it as a vector or a scalar, it is a vector. So this is, the value of this I is 1. When I take modulus for this I, the value is 10. So for any vector, if I take a modulus, I will get the scalar value. So this is for one dimension. Okay. Either if it is in positive direction, it is plus. If it is in negative direction, it is minus. So for only one dimension, I will be using only one unit vector or one axis. That is the concept in one dimension. If it is on horizontal plane, if it is on the vertical plane, what I will be using for y axis? If it is in, please listen, if it is in y axis, so you may find it out. So it is only for only one axis. If the axis is like this, if the axis is like this, if this is y and this is minus y, what is a unit vector? The unit vector for only one dimension is here, no x dimension. So if this is 0, This is plus y and this is minus y. To represent the direction of this is upward and this is downward, bottom. So for y axis, the unit vector is j. That is for y axis, the unit vector is j. I will write in bold, make a note of this, j. Then for the third one is the third dimension. So for y axis it is j, and this is plus j and this is minus j. Clear? The third one is z axis. The z axis is the axis that is perpendicular to both x and y. Okay, that is the third dimension. The unit vector is k. K is a unit vector in z axis. K is a unit vector in z axis. So this is how we represent a unit vector and a small alphabet with a cap at the top. So in some of your books, the unit vector may not be introduced with a tab, and otherwise they would have given the unit vector with a bold font. So you have to take it by yourself. If it is represented with a bold font with a number, the number is a scalar and the neighboring alphabet is a unit vector. So it's a standardized one. I is for x, j is for y, and k is for z. So I will tabulate it. X, y and z. Axis. Unit vectors. I, j and k. Don't ever forget these three. Okay? The dimensions will be like this. X, y and z. Clear, students? All are three mutually perpendicular axes. All three are mutually perpendicular axes. What is mutually perpendicular? X is perpendicular to y is perpendicular to z, and z is perpendicular to x. You can represent by this name. And this seems to be a corner of your room. Okay? When you take a rectangle, you will take when you see a corner, you will find this. Okay? In the forthcoming session, I will explain you clearly. So, please make a note of this very clearly. When you go for the opposite side, the sign just will be a negative one in any axis. So that's all about the one dimension. So when you analyze each and every dimension, you have to consider only one dimension with one unit vector. Next one is two-dimension vectors. Okay? So what is a two-dimension? It has two axes. The first one is x-axis and the second dimension is y-axis. That is a horizontal and a vertical line. Okay? That is two lines are there to represent a point. So in one dimension, to represent a point, you represent a point in any of the points in a single line. You represent a point in a place in any of the points in one line. Okay? This is one dimension. In two dimension, you represent a point by using two dimensions, that is using two lines as a reference. Okay, the main thing you have to use is the reference point. So let this be a starting point, 0, 0. As if you had 0 for x, the starting point, we also have a 0 for y. And previously I said the unit vector in the direction is x. That is for I. Then unit vector in y is j. The unit vector along x is I, along y is j. Clear? So now I will draw the unit vectors. This is I cap. This is j cap. So this value is 1. Now randomly I take a point here. Let this be a point P. Let this be a point P. I will draw it quickly. Let this be a point P. How to locate this point? I have a reference vector from this point to that point. I will now draw a line from this point to this point, starting point. This point be O. This point is represented as point O. Okay? So this is a position vector from this point to this point, OP. This OP vector is the position vector. Okay? So how do I represent? Because this point has two positions, that is x position and y position. Okay? X position and y position. So in x, you just directly draw a line. Then to know the position of the point above the ground, that is, you draw a line normal to the y-axis. You draw a line normal to the y-axis. So this is the x point and this is the y point. That is x comma y. Okay? So this point is x comma y and this is variable. You can place this point anywhere. Here, anywhere in this board. So this board is itself a very good example for two dimension. That is, it has a length and it has a breadth. Okay? Clear? So this point is represented by x dimension and y dimension. For example, let this be a 4 centimeters. This point is 5 centimeters. How do I represent? In general, I will represent as 4, 5. To represent this as a vector notation, what is the x coordinate? The x coordinate is, I represent as OP vector equal to, okay, the x value into I cap plus y value into j cap. So I have to write the x value into I cap plus y value into j cap. So the position vector is represented as x component. What is the x component here? 4 centimeters. Okay, 4 centimeters. That is 4. What is y component here? Y component is 5. Clear? So there is, you consider this graph alone. This graph denotes xy plane, that is 2 dimension. A plane is a 2 dimension. So it has an x component and y component. This point has 2 coordinates, x comma y, that is 4 and 5. So how to write this? 4 I cap plus 5 j cap. The 4 is the x component, 5 is the y component. Since it is a vector, I cannot write it as OP vector equal to 4 plus 5. This is a wrong way of writing. Since it is a vector, I have to introduce the direction vector. This 4 is in the direction of x. 5 is in the direction of y. Clear? So this is the correct way of writing the position vector. Then, what is the resultant vector? So, if OP vector is xi plus yj, this may be any value, xy may be any value. This is the standard form. If I want to find the length of OP, I have to take a modulus. That is modulus of OP is square root of x square plus y square. This is the formula. Clear? This is the formula for finding the length of this OP. Then the third one is, if this line position vector OP vector is with an angle theta with x-axis. If this position vector is angle theta with x-axis, I want to find the angle theta. So this line is what is the value of this line? This is phi, because this is parallel to the phi. This line phi is in parallel to the phi. The same length is there. Okay. So this is phi and this is 4. And I will draw the triangle separately. This is a right angle triangle. This is a theta. This is 4 and this is phi. I will take a tan of the triangle. Taking tan of the triangle, tan theta equal to, what is tan theta? I will write it as opposite by adjacent. Tan theta is opposite by adjacent. So this is the formula. Tan theta is opposite by adjacent. Then you write what is opposite? Tan theta is opposite is phi divided by 4. Then you can find the angle theta. Theta is tan inverse of phi divided by 4. So this is the formula for finding the angle theta. So in this problem I have given values for 4 and 5. In general, how do we write the angle formula? Theta is tan inverse of y by x. So this is the standard formula. So first thing is to find the modulus, that is the length of the position vector, use this formula. To find the angle between the line OP and the x-axis is tan inverse of y by x. So this is the concept behind the two-dimension vectors. So I repeat the concept. A two-dimension vectors includes x-axis and y-axis, or if you take any two axes, a two-dimension involves only two axes. For positioning a point in two dimension, you need a two axis. Okay? Then a position vector will be drawn from the origin. So to find the length of the origin, length of the position vector, use this formula. Then to find the slope of that, then you want to find the slope of that position vector, use this formula. Clear? Next thing is, I will teach you the three-dimension vector. What is three-dimension vector? Please pause the video and make a note of the formulas that I have written clearly. So always be cautious. You write the unit vectors with a cap. In books, some places they would have not mentioned the unit vector with cap. Otherwise, they would have introduced the unit vector in the bold font. The font will be in bold. Okay? So both are same. Next one is three-dimension. Now students, let us discuss about three-dimension. So previously I discussed about the two-dimension, that is only two axes are there. Here I introduced another axis, that is Z axis. Z axis is the third dimension I introduced. So it means I have x axis, y axis, then I introduce another axis which is perpendicular to xy plane. This is perpendicular to xy plane. This is xy plane. Okay. So that is perpendicular to xy plane, that is z axis. It means you consider this is as a cube. The shape itself represents a cube. So how to locate the points in a cube? The very best example is a room. Okay, you consider the room that you are staying. You have the three corners. You have the corners of your room. When you see the corner of your room, you have three axes that will be starting from the corner point. That is x, y and z. Clear? Three lines will be emerging from your corner point. X axis, y axis and z axis. So you can directly visualize or see the corner of your room. You consider this a corner of your room. So how to locate any point in the 3 dimension? 3 dimension means already you had x and y dimension. Now when I introduce a z dimension, the point will be shifted to another place. The point in the xy plane will be shifted from the xy plane. So when I consider this pen is in the board itself. Okay, this pen is in the board itself. Let this be a point object. This pen is placed in the board itself. Okay, this point can be, it is above the ground and from left side that it has 2 dimensions, x dimension and y dimension. Okay, the vertical direction it is y direction and the horizontal direction I can represent by x direction. So x comma y. Then if I bring this pen from this plane, this is xy plane, this is xy plane. When I bring this pen from the xy plane, it has another dimension, that is z dimension. How far this point is shifted from the xy plane, that is z dimension. Clear? My head is in a 3-dimension point. My hand is in a 3-dimension. If I place my hand on the board itself, the position of the hand it is in 2 dimensions. When I bring it is 3rd dimension. The 3rd dimension is introduced. It is so far shifted from the board. Okay. So similarly, I consider a 3rd dimension, a corner of a room. This is called rectangular coordinate system. So corner of a point. Now I fix a point A. It has a dimensions x, y and z dimensions. Each and every axis has its own unit vector. So for x axis it is I vector, for y axis it is j vector, and for z axis it is k vector. Previously I discussed you, for z axis it is k vector. So k vector represents the unit vector in the direction of z. Okay. So now I take a point in the from corner to here. So it is a random point x, y and z. I close the loop as a rectangular system. So for each and every point I have written you what is the position vector. What is the position vector? How the position of each and every point is described in this diagram. You see, on x-axis, you just take only the x-axis. Clear? You just consider only the x-axis. Y and z are there. You just take only the x-axis. So if the point lies here, there is no z component and no y component. So x comma z comma y comma z both will be 0. Clear? So this point is x comma 0 comma 0. If I raise this point to upward, if I raise this point, what happens? That point has a y coordinate. So it has, because a y coordinate will be there for that point. X coordinate will be there, y coordinate will be there, and z coordinate is 0. The point is not come forward from that 2-dimensional plane. Then if I bring this point, if if I bring this point above from the towards the outside from the board, outside from the plane, it will be having a what? You just visualize this. It has a x, y and z. So this will be very convenient for you to listen. So at y direction, the x and z are 0. Only you will be having y. At y z plane, this is y z plane. Clear? This is y z plane. In y z plane, we will be having x coordinate is 0. Only y and z will be varying. In x z plane, at the floor, it is at the floor. Okay? This is floor. I will write it clearly. This is a floor. So in the floor, the point is not raised. So what is the plane? It is x z plane. So what is the value of x is having, y is 0 and z value is having. Clear? So the point in the floor is, there is no y value. The point is not shifted. If I move the point in the floor, it does not have the y value. The point is not raised up. Okay? So the dimension of the floor is x and z. Clear? Then this point is x, 0, z. Then I come to this point. This point has three variables, x, y and z. It is floating in the air. This point is floating in the air. Okay? So it has all the three dimensions, x, y and z. So how to represent? So I am representing from 0 to a and drawing a line, that is position vector of this point a. I am representing with a line OA vector. Okay, that is, it has x component, y component and z component. That is ax times I cap, ay times j cap plus az times k cap. Because the ijk should be introduced to represent the components of the x, y and z. The magnitude formula is OA. When I take the magnitude modulus, I will get the magnitude ax square, square root of ax square plus ay square and az square. Then what are the components? This OA line has this OA line makes three angles. This OA line makes angle alpha. This is alpha. Okay. The angle is, this is alpha. This is beta. This is gamma. Alpha, beta, gamma are the three angles. So alpha is the angle made by OA with x-axis. Beta is the angle made by OA with y-axis. Gamma is the angle made by OA with z-axis. So with this we can find the component of OA with each axis. When you know the angle made by OA with each and every axis, you can find the component of OA along the axis. Okay. So ax is magnitude of OA times cos alpha, cos of that alpha. Ay is magnitude of OA times cos of that beta. A is the magnitude of OA along z axis is magnitude of OA times cos of gamma. So these are consolidated formula. Please kindly make a note of this formula and be very clear in writing the formulas. Do not get confused when writing this. Always you take the magnitude of the value. Don't directly write the values for the vector. Okay? You should take only the magnitude for finding the components. Do not introduce a vector here. Clear, students? Do not introduce the vector here. Write the magnitude only. I will show you a simple example. If, for example, the point A is located as 3, 2, 5. This is an example. You can get into the concept very easily. What is the magnitude? OA is square root of 3 square plus 2 square plus 5 square. 3 square is 9 plus 4 plus 25. 25, 34, that is answer is 38. This is the answer. Okay. So then, if alpha is magnitude of OA is 38. If alpha is 30 degree, then AX is modulus of OA is what? Root 38 into cos 30. Okay. So that is cos 30 is root 3 by 2. So root 38 into root 3 by 2. So this is the concept. Please make a note of this, students. This is just an example. How do I implement the formulas for finding the magnitude and the angle? Now the angle component AX. That is root of 114 by 3. This is the answer for this. So I repeat the concepts. So one dimension. So one dimension involves only one line. Okay? It is represented by a position vector with one unit vector. Two dimension. It has a two lines or two dimensions. It is represented by a position vector with two unit vectors. Then the last one is three dimension. A three dimension has three lines, that is three unit vectors. Okay, a point is represented by with reference to three dimensions or three axes. So you need three unit vectors to represent a three-dimensional vector. Clear, students? Please stick on to the basic formulas very clearly, and if you have any doubts, please make a note of the doubts. Okay, whenever you meet us, you get it cleared. Okay, try to solve the problems that we give. Okay, thank you.